Hello everyone. Today we are going to do the third lab of CHE 446. The objective of this lab is to identify a first order plus dead time black box model using the collected data for the relationship between the acidic flow rate and the temperature of a single tank system using the step-test response. So in this lab, we will address the estimation of process transfer function under the different operating conditions. Okay, let's do the experiment. To start the lab, we should fully open the steam flow rate hand valve, and also we should open all other steam in this lab. Based on the procedure, we should fully close the short hand valve, and based on the table 1 nominal conditions, for the long hand valve we should open until 35 degrees. Okay, right now we can run the experiment using Delta V operating system. In this lab, the data will be collected automatically by Delta V system. For the station P1, we should put the cold water flow controller FIC104 on cascade mode. So I select cascade here, and the level controller LIC101, this one, should be on auto. So we should set the level controller set point to the nominal condition given in table 1. Based on the table 1, water level in the nominal condition is 0.2. So we put 0.2 as the set point of level in the tank. So the water of flow rate is coming. So now, as we see, the controller is trying to open the control valve and increase the flow rate of water such that the level of the water in the tank reaches to the steady state. And as we see here, the output of this controller, which is the level in the tank, is 0.196, and it is trying to reach out to the set point, which is 0.2. So once the level of water in the tank reaches the set point 0.2, now we can start the step 3. In step 3, we specify the flow rate of the steam. So we put the steam flow rate controller FIC105. This is the controller of steam flow. So we put this one in auto based on the procedure, and its set point equal to the nominal value in table 1, which is 15. So the set point is 15. So now the controller of the steam open the valve, open the steam valve such that and try to increase the flow rate of steam to reach us to the set point, which is 50. So as the controller increases the flow rate of the steam, the temperature of the tank, we can see here, we are using the thermocouple to measure the temperature T101. Here we are seeing the temperature of water, and it is increasing because the flow rate of steam is increasing in the tank. Initially the temperature was 25 centigrade, and right now it is about 32. Next, we are giving a sub-response test to the system in the nominal conditions. So once the steady state has been reached, we increase the set point of steam by 5. So I increase it to 20. And we should wait until the output, a simple rate returns to the set point. Then we have negative step change. So we decrease the set point of steam by 10. So it was 20, I put it 10 right now to have a negative step change. And again, we should wait until steady state is reached. And finally, again, we increase the set point of steam flow rate to have a positive step change by 5 kilograms. So here right now it is 10. I increase it to 15. And again, we will wait for a steady state. So the nominal condition is done. In this condition, we had 3 steps. First, we had positive 5 step, then we had minus 10 step, and again we increase positive 5 step. So now we can switch to worst case. For the worst condition, based on the table 1, we should open the long hand valve to 50 degree. So I change it to 50 degree here. As well, we should change the steam flow rate controller FIC 105 in the worst condition based on the table 1, which is 10. So I should change this one to 10 based on worst case in the table 1. But for water level LIC 101, if we pay attention to the table 1, the set point is the same as nominal condition. This is 0.2. So we don't need to change the water level LIC 101. It is the same because in the worst case and in the nominal case they are the same. So once the system reaches to the newest steady state 10, we repeat the previous procedure for the step changes given in table 2. So as a first step, we should increase by 5. So I increase from 10 to 15, and I should wait for reaching to the steady state now. In the next step, we should decrease the set point by 10. So from 15 we go to 5, and again wait for reaching to the set point. And as the last step, we increase the hot steam inlet flow rate by 5. So we will go to 10 for set point. This is the last step of worst case, and after that I will show you that how we collect data and how we use it. So now I'm collecting data. In this lab, the data will be collected automatically by Delta V. So I open the experimental data and station P1 that I was working on. So here we have some data. We need to determine end time. This is the duration, the time of experiment. So I choose 120 minutes and set current time. So here we can see our collected data. For example, column E. This column is the esteem flow rate, which was 0, and increase it to 15, because as the nominal condition we increase the esteem flow rate to 15. So I copy all this data and upload it onto the eClass. Thank you.